Okay, so welcome back to maths, and today it is going to be compound angle formula. So, compound angle formula, this basically means it's going to be one angle plus another angle. So, this is written as sine of A and B. Now we're going to say there's a plus and a minus in here. I'll explain that because it's kind of important. So basically the formula goes that sine of A plus B is equal to sine A cos B plus or minus cos A sine B. Now what is the plus and minus about? If it is sine A plus B, so I'll just write this plus B, then it's going to be A, B plus A, B. I'm just writing in those instead of writing in the sine and cos every time. If it is A minus B, that means it's going to be A, B minus A, B. So that is what the plus and minus are for in this. So if it's a plus, it's a plus. If it's a minus, it is a minus. Then we have cos. Cos A plus or minus B is equal to cos A. Now remember, it always starts with sine, cos starts with sine. Cos B minus or plus sine A sine B. Now what on earth is this? Why is it like this? So this means that if it's going to be A plus B here, it's going to be equal to AB minus AB. Obviously, just again, I'm not putting in the cosine sign because it's too much to write. And then here, if it's A minus B, it's going to be AB plus AB. Just because cos, you have to remember with cos, it's just the other way around. So it's a plus, it's a minus. If it's a minus, it's a plus. That is why here it's plus or minus, and here it is minus plus. Always good to have that in mind, and it's just an easier way of writing it instead of writing out both ways of doing it. So then we have tan. You could prove this by using sine and cos. However, it is easier to just learn the formula, which is going to be tan A plus or minus tan B. And because tan is the awkward child, 1 minus or plus tan A tan B. So we have in tan, we have plus and minus, and we also have a minus and plus. So if it was A plus B, it would be tan A plus tan B over 1 minus tan A tan B. If it was A minus B, it would be tan A minus tan B over 1 plus tan A tan B. And that is literally just because tan is the awkward child. Okay then, so using this, you're able to do some interesting things. So the question could be, work out cos 75, and it might say without calculator. Yeah, what does that mean? Why without calculator? It basically means that it wants you to put in values and use algebra to solve it rather than literally just typing in cos 75 equals. So cos 75 is equal to cos, we're going to say 30 plus 15. It's not 30 plus 45. That equals 75. But we're just splitting it up. And if you were to type into your calculator cos 30, you would get root 3 over 2. And if you were to type in cos 45, you would get 1 over root 2. So we can rewrite this as cos 30 cos 45 is plus minus, and then it's going to be sine 30 sine 45. So on the old course you just have to know these. On the new course you actually don't have to. So you can just type cos 30 into your calculator. That gives you root 3 over 2. Type cos 45 into your calculator. That gives you 1 over root 2. Then they're going to be multiplied together. Minus sine 30 is equal to 1 over root 2. And no, that's sine 45, sorry. And then sine, I'll swap those around. Whenever I was working these out, I actually written down the other order. That's going to be sine 30, which is a half, multiplied by sine 45, which is 1 over root 2. So then you're just going to multiply them together, so you get root 3 over 2 root 2 minus 1 over 2 root 2, and you get root 3 minus 1 over 2 root 2, simply by taking them away for each other. If you were to type cos 75 into the calculator, you would get this, but you'd actually get it written as, I think it's root 6 minus root 2 over 4. But it's the same thing, it's just they've rationalised the denominator. Okay, so the next question with this would be something along the lines of, what is tan 15 without using your calculator? They can be written as tan 45 minus 30, because that is going to be equal to 15, and so that can be written as tan 45 minus, so it's going to be minus tan 30, divided by 1 minus, so it's a plus this time, tan 45 tan 30. Now you can type into your calculator what each of those values are, and you will get 1 minus tan 30 is root 3 over 3, divided by 1 plus tan 45 is 1 multiplied by root 3 over 3. Now, you can simplify that, it being 3 minus root 3 over 3 divided by, so we're going to multiply that by 3 over 3 plus root 3. Please cancel that over that is going to be equal to 2 minus root 3 if you were to type that into your calculator. And that is your answer. And so from these, we can form the double angle formula. I'm just going to write it as that because it's too long to write out. So to make a double angle, it's going to be sine A plus A, and then you write it out as normal. So you would write, let me see, sine A cos A plus cos A sine A. And if you notice, sine A cos A sine A, same thing, 2 sine A cos A. Now this formula is not given in the formula book, that one is, so you can work it out if you need to, but it's also pretty simple to remember. 2 sine A cos A, so we will write that in over here. Sine of 2A is equal to 2 sine A cos A. Nice and easy to remember. Okay, now let's go for cos. Cos A plus A is going to be equal to, well, we'll write it out this way, cos A minus sine A sine A. Filling into there, as you see, if it's got plus, it's a minus. Remember, there'll never be a minus in here because A minus A is 0. But yes, cos A sine A, that is equal to cos squared A minus sine squared A. That is also not a cos, I wrote sine. Let's just rub that out. That is cos squared A. So we'll write that up here too. Cos of 2A is equal to cos squared A minus sine squared A. And now to fill into tan. Tan of A plus A is equal to tan A plus tan A over, filling in A here, 1 minus tan A tan A. Simplify that, we have 2 tan, that's not a tan I cannot write today at all. We have 2 tan A on the top, and on the bottom we have 1 minus tan squared A. And so we can write that in here. Tan 2A is equal to 2 tan A over 1 minus tan squared A. And now you can start to solve equations with this. So we have the equation 3 cos 2 theta minus cos theta, and that is plus 2 equals 0. We're looking for this. 0 is less than or equal to theta is less than or equal to 360 degrees. We're working in degrees this time, not radians. So first thing you do, cos 2 theta, we're going to rewrite that as 3 brackets cos squared theta minus sine squared theta minus cos theta plus 2. Now, sine squared theta, we know, can be rewritten as 1 minus cos squared theta. So 3 cos squared theta minus 1 minus sine. That's what we're rewriting, 1 minus cos squared theta. Sine is always the first one I write down, isn't it? Cos squared theta minus cos theta plus 2 equals 0. Forgot equals 0 there. So let's expand. We have 3 cos squared theta minus 1 minus 3 minus plus cos squared theta plus 3 cos squared theta minus cos theta plus 2 is 0. Rearrange this. 6 cos squared theta minus cos theta minus 1 is 0. Now, we can solve the quadratic, and I'll just write that cos theta, I'm not going to show you the brackets this time, just going to go straight to the answer because there's not enough room, is equal to half and minus 1/3. Now I'm going to rub this out and put this back up to the top. Okay, so that means that when we type this into a calculator, cos is equal to 60 degrees and 70.53, and that is negative, remember, because of the minus. So let's draw out our diagram. Our favourite diagram that we use so often, 0, 3, 60 is there, 180 is there. Okay, 60, let's put those in first. Cos is positive, so 60 and 60. And then we have 70.53 in the negative ones, here and here. So theta is equal to, round to this one, we have 60 degrees, then we have the next one, which is 109.47 degrees, then we have this one that's round here, that's 250.53 degrees, and we also have this one here, which is 300 degrees. And that is your answer. So that was one where you had to use the double angle formula to put it into your equation to solve. Okay, so apparently this is a popular question. Cos 3 theta, what is that equal to? Well, we know what cos 2 theta is and we know what cos theta is. So we could rewrite that as cos of 2 theta plus theta, and then you're going to write that out as you would the double angle formula, or the compound angle formula. So let's rewrite that as cos 2 theta multiplied by cos theta minus sine 2 theta sine theta, and then expand. So now we have, are you ready for this? Cos squared theta minus sine squared theta, that's still being multiplied by cos theta, minus sine squared theta is going to be 2 sine theta cos theta, and that's still multiplied by sine theta. Then when we expand, we get cos cubed theta minus sine squared theta cos theta minus 2 sine squared theta cos theta. But they want, and they may say that you can leave it like that, or they may say something like in terms of cos theta. That I did 2 different types of bracket. If they say that, you have to change the signs into coses. Not too difficult. Cos 3 theta minus 1 minus cos squared theta cos theta minus 2 1 minus cos squared theta cos theta. We know that we can just put that in because we know that sine squared theta is equal to 1 minus cos squared theta. So, rewriting this, cos cubed theta minus 1 plus cos, oh, that's not minus 1. I made the mistake that you're not supposed to make, the one where you forget what's outside the bracket. Let's fill that in again. So, minus 1 cos theta plus cos cubed theta. And then here we have minus 2 cos theta minus plus 2 cos squared theta cos cubed theta, so plus 2 cos cubed theta. And then You can tidy that all up by adding. So there's 1 cos cubed, 2 cos cubed, 4 cos cubed, and then minus 1 cos theta, minus 2 minus 3. And that is your answer. Just a lot of algebra, a lot of moving things about to get to the answer that they want. You could have been able to leave it there, unless it says that, in which case you want to bring it down by subbing in things for sine squared theta. Okay, now for a difficult identity. So sine 2 theta divided by 1 minus cos 2 theta is equal or identical to cot theta. Now we're going to work on this side because there's the 2 thetas and they're harder to work with. So sine squared theta is equal to 2 sine theta cos theta. That's being divided by 1 minus cos squared theta. Now, it should be minus sine squared theta, but because there's a minus, it's plus sine squared theta, because you're multiplying the entire thing by minus 1. If you didn't want to do that, you could put brackets around it, and then you'll see that the minus and minus could be a plus. So what do we do now? Well, we want cot theta. Remember that cot theta is cos theta over sine theta. So we want sine theta's on the bottom and cos theta's on the top. Well, here's a cos that we could change into sine quite easily. So 1 minus sine squared theta plus sine squared theta. Now we're just working on the bottom here. I'm not going to bother right at the top. You could maybe put this in brackets if you really wanted to. 1 minus 1 plus sine squared theta plus sine squared theta. 1 minus 1 is obviously going to disappear. Sine, that's going to be 2 sine squared theta. Theta at the bottom, let's bring that over to here, and we can write 2 sine theta cos theta divided by 2 sine squared theta. Now, you can start to cancel things here. So let's get a different colour pen. The 2 go. One of the sines is going to go with this sine, and so what you're left with is cos theta divided by sine theta, which is equal to cot theta, as we wanted to find up at the top. And that is an identity. There are loads of other ones. You just have to be careful to sub in these correctly. One with tan can get quite interesting, because there's a lot of lines and things like that. But those are identities.